All right, so today I want to show you how we are calibrating a load cell. So this is where we're at sparkfun.com, and this is a load cell. And if you actually look in the webcam, um, that same load cell is right here. And basically how it works is you can either compress it or pull it, and it's using something called a Wheatstone bridge circuit. And basically, you don't have to know what the Wheatstone bridge circuit is. All you have to know is at the end of this, we're going to get an analog voltage. And as you press on this or pull it, there's going to be a change in voltage. And we're going to measure that at the microcontroller, and then it calibrates linearly to weight. So I want to show you over at the app. So this is our all things IoT application. So for this specific use case, we needed a force gauge. So over at force samples, we've got latitude, longitude, and here's the A0 voltage. So we're 25, that's in millivolts. So that's 2.5 volts. And then over here, if we go to it, these are just different force depths. Don't get too hung up on that. That's more the application specific. We want to go into how we're calibrating it. So we have the analog voltage change, and if we come over to this calibrate section, because it's linear, we capture a resting millivolt. So we don't apply any pressure to this force gauge, and we take a measurement and we say, hey, it's like in here, it's 2,500. Then we apply 50 pounds of force to the force gauge, and then we observe the millivolts. We say it's 2,600. And then from that, we get this nice linear graph, which in our case, the saturation point of that pin, or the highest level, is 3.3 volts. So for this force gauge, and it's got a 200 kilogram limit. So for this force gauge, we have 400 pounds at full 3.3 volts, and if you're at 2,500 millivolts or 2.5 volts, that's 0 pounds. So we save that, and then then we have that formula to calculate. So like at this 5.5, we have like a 200 pound reading, and this is actually when I was like basically standing like on this thing. So we got 200 pound reading, and then it goes up and down based on that. So yeah, that is. When you think of Internet of Things and these hardware projects, there's primitives. Primitives being like with sensors, you can see things, or you can see their temperature, or you can see their weights, or you can see all these like primitives. So force is one of those primitives. Location, GPS, is one of those primitives. So pretty excited once we got this kind of figured out. We're still doing some testing, but the initial just getting it up and running, it was pretty nice, and it seems to work really well. See you next time.